For this video, we're going to look at, excuse me, question number 6 out of module number 3. So in this problem, we're asked to use logarithms to solve this problem, right? And so really, we don't have to put too much, worry into this because it has these e's and these, x's in the exponent. We can kind of think about this really in terms of if this had just been something like 2x minus 56, then that's not something very daunting for us to factor, right? And we could see that that factors to x minus 8 times x plus 7, okay? So we can use that bit of information to help us factor the given problem by using the FOIL method. So that would allow us to then factor this equation here, that's e to the x minus 8. So see, that's kind of like this first term here, times e to the x plus 7. That there is like our second term, okay? And we'll set that equal to 0. Therefore, we know that the product has to equal 0, right? So at least one of those two terms has to be equal to 0. So I know that e to the x minus 8 is equal to 0, or e to the x plus 7 is equal to 0, okay? So I can add 8 to both sides here, and I can minus 7 from both sides on the other one, so that we're really just getting e to the x is equal to 8, or e to the x is equal to negative 7, okay? So remember, rules of that we have when we're dealing with e and logarithms and things like that is that we must reject any negative solutions, right? So here we're going to have to reject this one that says e to something is negative 7, right? So we have to reject this one, okay? So that really only leaves us one option, and that is that e to the x is 8. So, but the problem here, we need to just take it one more step further, right? Remember, the inverse of e is ln. So if we take the ln of both sides, right? Because whatever you do to one side of the equation, you must do to the other side of the equation, and it still keeps it in balance. So what we have, we can then use our exponent rule, right, with the ln's. And that means that we can bring this exponent down into the front. And so that gives me x is equal to, actually it gives me x ln of e is equal to ln of 8. But if you recall from the lessons, ln times e, or ln of e, that is really just equal to 1, right? So put that in your calculator. You could put ln and then the variable e, hit enter, and you will see your returned a value of 1, okay? So we can simplify this to say that x is equal to the ln of 8. And that is what Mobius is looking for. You may actually, Mobius might require you to put the 8 in parentheses. And then another thing that a lot of people don't see sometimes, because we're seeing it in print form, is that is the ln and not a capital I-N, okay? So if you type an I in there, then Mobius is going to count that incorrect. So you'll want to make sure and get that as a lowercase l and then the n.